Hello everyone, I am Bradley Sward, and this is my Day 19, Part 1 Solution to Advent of Code 2024. The problem is known as linen layout. I'm solving this today, almost as always, in Python. So the problem is substrings and strings and recursion all the way down the road here. So I have a bunch of, you want to think of them as patterns. I have, whatever, and like, can I make a specific word using any combination of the patterns that you're given? And so like in this case, the BR can be made from BR, then WR, and then the R. But like this one here, there's no U to start this thing, so I can't make anything that, even though there's BUW here, there's no pattern that allows me to start from a U and make this thing work. So there's nothing so that one's not allowable. So from this data, 6 of the 8 are good. And from my data, 247 of them are good, and I can show that here. There's not a lot of code to go from here. So basically what I'm doing is I'm basically getting the patterns from the first line and the words I'm testing against in lines 3 through whatever. And then as we move on here, basically I'm testing. This is a function. You give me a word and you give me the patterns, the patterns you want to test against. And if the pattern, I'm going to test each pattern in the word again, and I'm going to reduce the word by the pattern if it's found. And so, and if there's nothing found at all, it's going to return an empty list. So just to show here, when I run this for the first time here, that when you hit this thing, you can see that the reduce, its list, there, the word itself started with a G and an R, and then like this reduced down and reduced at least the G, maybe the R. I mean, again, it depends on what the patterns are. As you can tell, this is crazy, and I'm not going to bother looking at it. But you can see that there's a bunch of stuff going on in there. So that's how the reduction function works. But like in this case, the recursion here, right? Like true or false? Does this thing return? Does this thing return? Is this correct, right? So let me you get 247 in a couple seconds here. So there you go. So, but just to say here, if the word is found and reduced, instead of returning an empty list, it will return an empty string. So like as I'm recursing my way down, I'm saying, well, if the word is an empty string, well then it's a valid word. Or we found a pattern, and we're going to return true, saying yes, we did find a pattern. But otherwise, we're going to try all the other whatever's in that list, whatever's in this test word as we're reducing around, we're going to try all the reduced versions of that. And if I ever find out that one of them's true, then it is true. But if I work my way down all the way through and I don't find anything, well then there's no recursion, or there's no trueness to this, and the word can't possibly be made. And all you're doing is summing them all up, trying it all out, calling recursion, have the recursion call itself a million times or however many times, and get your solution. So that's my part 1. Part 2 looks a little trickier only because of the size of the words that were put in front of us. I'm going to be looking into that now. Hope this video helped anybody, and I'll see you guys in the future. Thanks. Have a good one.